Well, and they give you an equation up top. To start off, you have to balance out the equation first. So we would put a 2 in front of iron oxide, and then a 4 in front of iron, and that balances out the irons. Now you move on to the oxygen, and there's 6 on this side, so there has to be 6 on this side. So that would be a 3. Now you know that there's 53.6 grams of iron. And it says how many grams of iron oxide can be produced. Well, to go on to the next step, you have to look for the molar mass. And to find that, you have to look at the periodic table. As you can see, iron is 55.8 grams over mole. Oxygen is 16.0. And to find iron oxide, you would have to do 16.0 times 3 and 55.85 times 2. Once you put that in your calculator, it will give you 159.70 grams over moles.
Alright, hi, I'm Freddie, and I'm going to continue the problem that Aaliyah was doing. I'm going to show you the stoichiometry step of the problem. Alright, they gave you this number, 53.6 grams of iron. They gave you this in the problem. Alright, then you're going to set up your mole ratio. How we found out this earlier, 1 mole of iron has 55.85 grams of iron. Okay? And then you get that, and then you have to get the moles that you got in the reaction once you balanced it. So 2 moles of iron oxide and 4 moles of iron. Alright, once you get that, you move on and you do the total grams of iron oxide that was in the reaction that you figured out over here. And you put that over 1 mole of iron oxide, because that's what you're trying to figure out. How much grams of iron oxide can be produced. Then you're going to type this in your calculator, exactly how it is, and you're going to come out with 76.6 grams of iron oxide.
Hi guys, my name is Janice and I'm going to be teaching you about limiting reactants. First off, a limiting reactant is a reactant in the chemical reaction that limits the amount of product that can be formed. And since there is a limiting reactant, there has to be an excess reactant. And the excess reactant is the reactant in the chemical reaction that remains whenever the reaction stops, when the limited reactant is completely consumed. There's an excess reactant because there's nothing it can react with. Okay. So I'm going to do an example for you guys. Okay, so a 2.00 gram sample of ammonia is mixed with 4.00 grams of oxygen. And then you have to find the limiting reactant and how much excess reactant remains after the reaction stopped. Okay, so first they gave us the reaction already. So we have 2 grams of ammonia, and they give us 4 grams of oxygen. Okay, so we're going to start off with the 2 grams of ammonia. So you turn that into moles. So 1 mole of ammonia is equal to 17 grams because nitrogen is 14 grams and 1 atom of hydrogen is 1, so 1 times 3 is 3, plus 14 is 17. So then you do stoichiometry. So you go back to the problem and you have 4 moles of ammonia and 4 moles of nitrogen monoxide. So it's a 4 to 4 mole ratio. So 4 over 4 is basically 1. So you can go ahead and cross that out. And then you find the grams of nitrogen monoxide. So 14 and oxygen, one atom of nitrogen is 16, so 14 plus 16 is 30. And then you multiply all of it out, so you have 2 times 1 times 1 times 30 over 17 times 1, because you cancel those out, times 1. And you get you get 3.5 grams of nitrogen monoxide. So now we're going to do the same exact thing, but with the 4 grams of oxygen. So you find the mole, so 1 mole of O2 is equal to 32 grams. Because 1 atom of oxygen is equal to 16, so 16 times 2 is 32. And then you do stoichiometry again, so 1 mole of, I'm sorry, it's not 1. You go back to the problem for this. So 5 moles of O2 to 4 moles of nitrogen monoxide. So 5 to 4. You find the grams of nitrogen monoxide. So 1 mole of nitrogen monoxide is equal to 30. And you just multiply all of that out, so 4 times 1 times 4 times 30 over 32 times 5 times 1. And you get 3 grams of NO. So now that we have all that, okay, so this is how much you need of oxygen, this is how much you need of ammonia, but this is how much you have. So you have 3 grams of nitrogen monoxide for when you need 4. And over here you need 2, but you have 3.5. So you have more than enough for the ammonia, which means it's the excess, but you need more for the oxygen, so this means it's the limiting reagent. So oxygen is the limiting reagent. Okay, so now the question wants us to find the excess reactant that remains. So we're going to start off with the 4 grams of oxygen, and you convert that into moles. And we're basically going to be doing the same thing, except instead of converting it into nitrogen monoxide, you can convert it into ammonia. So 1 mole of O2 is equal to 32 grams. And then you do stoichiometry, so it's 4 moles of ammonia and 5 moles of O2. And 4 moles of ammonia. Now you find the grams for ammonia, which is 17 grams for 1 mole. And then you just multiply it out. 4 times 1 times 4 times 17 over 32 times 5 times 1. Okay, so 4 times 4 times 17 over 32 times 5, and you get 1.7. So we have 1.7 grams of ammonia left over. And that's it.
Hi, I'm Christina, and I will be explaining percent composition. Percent composition is the percent by mass of each element in a compound. So an example problem is find the percent composition of carbon in carbon dioxide. What it's asking is how much of carbon dioxide is made up of carbon. So to find it, we have to find each molar mass of each element, like Aaliyah did. Carbon is 12.01 grams, and oxygen is 16 grams. So we have 12.01 for the one carbon, plus 16 times 2 for the 2 atoms of oxygen to give you a total of 44.01 grams of carbon dioxide. And all you do is take, since we're trying to find carbon, we take the mass of carbon over the total, which we just found out, and you get 40% of carbon in carbon dioxide. Okay, I'll be explaining to you what percent yield is. Percent yield is the actual mass of product divided by the predicted or theoretical mass of product times 100, as shown right here. It helps you determine whether the reaction was successful or not. So our example question is, what is the percent yield for the predicted formation of 21 grams of C6H12 when the actual is only 3.8 grams? So using the equation up top, we get the actual mass, which is 3.8 grams over the theoretical, which says over there 21 grams. Times that by 100, and you'll get 18%, which shows that the formation wasn't as precise or successful determining since it's only 18. And that's it.
Okay, so I'm going to be teaching you how to do empirical formulas, and an empirical formula is basically a formula with the simplest whole number ratio of atoms in the compound. Okay, so we're first going to go through the steps. So the first one is to start with the number of grams of each element given in the problem. So in the problem, we can say this compound has this many grams of this element, this many grams of this element, and so on. But in some of them, they're going to give you percentages, and you're going to assume that it's out of the total mass is 100 grams. So I'll explain that to you in the second example, and then after that, you're going to convert the mass of each element using the moles. So basically, we can do stoichiometry, getting the moles and turning them into grams, and that's basically it. And then you can divide. After that, you're going to divide each mole value by the smallest number. So let's say, like in the first example, we had 0.325 and 2, which was calcium, and 6.75. So the smallest one was obviously 0.325. So you divide everything by that to make the smallest one 1 mole, and you're just going to find everything from there. And then you're going to round to the nearest whole number, because you can't have 0.5 grams of an element. You can't. Not whenever it's the empirical formula, because it's a whole number ratio. So if the number is too far to round, like 0.1 through 0.9, then multiply each solution by the same factor. So if you get one solution that's 1.5, then you multiply everything by 2 to get 3. Or if one solution is 1.25, then you multiply each number by 4 to get 5. And I'll show you that whenever we get to it. It says NutraSweet is 47.14% carbon, 6.16% hydrogen, 9.52% nitrogen, and 27.18% oxygen. Calculate the empirical formula of Nutri-C and find the molecular formula. And then the molecular mass of the entire thing is 24.3 grams. Okay, so now, since they do give us percents, we're gonna say that it's out of 100. So we have, so when it's out of 100, because all of this is 100, all of it together, because it's a percent. So we have, so assuming that's out of 100, so we have 47.14 grams of carbon, 6.16 grams of hydrogen, 9.52 grams of nitrogen, and 27.18 grams of oxygen. Okay? So now we go and find the moles of every single one of these, like in the first problem. So 57.14 grams of carbon. So 1 mole of carbon is 12 grams. So 57.14 divided by 12, and you get 4.76. Okay, and then you have 6.16 grams of hydrogen. 1 mole of hydrogen is equal to 1 gram. So you have 6.16 moles, I'm sorry. 16 moles of hydrogen. And now with basically doing the same thing for all of them. So 9.52 grams of nitrogen. And 1 mole of nitrogen is equal to 14 grams. And you get 9.52 divided by 14 is equal to 0.68 moles of nitrogen. And then you do lastly with oxygen, so 27.18 grams of oxygen. 1 mole of oxygen is equal to 16 grams of oxygen. You get 1.69. You get 1.69 moles of oxygen. So now we're going to go and divide by the smallest one. So the smallest one is obviously 0.68. So this one's 1. So 4.7 divided by 0.68, you get 6.9, which is approximately 7. 6.16 divided by 0.68 is 9.05, which is approximately 9. And 1.69 divided by 0.68 is 2.5. And since we can't really round this because it is halfway through, you're going to have to multiply all of it by 2. This is 14, this is 18, this is 2, and this is 5. So because you can't round anything that's this close. So you're going to have to multiply everything by 2 to get a whole number. So now we have carbon, which has 14, hydrogen, which has 18, nitrogen, which has 2, and oxygen, which has 5. Okay, so now let's find the molecular formula. So the molecular formula is basically the molecular mass and the empirical mass. So they give you the molar mass, which is 294. Alright, so it's molar mass over empirical mass. Okay, so they give you the molar mass, which is 294.3. Over the empirical mass. So for the empirical mass, basically just go through and find how much this weighs. So it's 12 grams of carbon. So for carbon, it's 12 times 14. For hydrogen, it's equal to 18 times 1, because 1 gram. Then nitrogen is equal to 2 times 14. And oxygen is equal to 5 times 16 grams. Okay. So 12 times 14 is equal to 168. That's 18. 28. And 5 times 16 is 80. So you add all of this up. 18, and you get 294. So you divide this, and you get 294.3 divided by 294. You get 1.01, which is basically 1. Okay, that's basically it. Multiply that, converting it into
Teachers, at this
nitrogen.
time, please release the students to go to 6th period. Once